Good afternoon, everybody. This is Rudy Shankar. I'm the director of the ESE program at Lehigh University, and we are presenting the last in the series of seminars this fall. And the title of the presentation is Rebalancing the Energy Trilemma, Strategies for Navigating the Changing New York Energy Landscape. And the speaker is Laura Marsiglio. And before I kind of read out her biography, I just want to remind you that this seminar will be for 90 minutes, 60 minutes nominally for the presentation, and 30 minutes for Q&A at the end. And so I'd like to have, during the Q&A, students take the first dibs for asking questions. Then I'll turn it over to the general audience. So about Laura. Laura is, of course, a well-known person to our seminar series. She's presented them several times, and she's an alumni of this program. So we're very proud to have her back here. And she is an associate and analyst on National Grid's New York transformation team, where she works with stakeholders across the business to develop short-term strategy and robust long-term plans to facilitate a clean energy transition. She earned a BS in Integrated Engineering and Social Science from Lehigh University's IDEAS program, studying materials engineering, economics, and environmental policy. She also earned an M.Eng in an ESE from Lehigh University in 2022. Laura, the floor is yours.
Thank you so much, Dr. Shankar. I appreciate the kind introduction. Let me go ahead and share my screen. Can you see it okay?
Yes.
All right, perfect.
And real quick, you might want to speak up a little bit because you got real quiet.
Okay. All right. If at any point you can't hear me, just let me know. So we'll go ahead and get started. I appreciate the introduction. I'm always excited to, come back and talk about what I've learned in the industry because this program was so valuable for starting me off on the right foot. So hopefully I can share what I've learned since leaving. So as Dr. Shankar mentioned, I work for National Grid as a senior analyst on our Future of Electric strategy team in New York. So my team's role is to help our electric business develop a strategy that helps us to meet regulatory requirements and also the needs of customers. So I spent a lot of time thinking about and talking about how we can navigate some of the challenges and changes in the energy landscape as a business. My focus specifically is on supporting around 20 initiatives that are delivering operational and capital efficiencies. I'll talk more about that later in the presentation, but the goal here is to reduce the cost per unit of work by incorporating digital tools and innovative technology that drive process improvements and ultimately drive down costs. So in my presentation today, I'm going to talk about what the energy landscape in New York looks like right now, as well as some notable changes over the last year or so. There have been, some things happening with the change in federal administration. And then I'll also talk about the challenges that utilities are facing in this environment and some of the solutions that we're exploring and implementing. If you read energy news at all, a lot of the headlines recently talk about rising electricity prices and the impact of data centers and AI on reliability. And it's been interesting to kind of see that change because when I started at National Grid 3.5 years ago, we were talking mostly about how to interconnect renewables as quickly as possible and manage growing load due to electrification. And we're still thinking about those challenges, but it's been interesting to see just in my time since graduating how quickly the landscape has changed. So that's, what I'll be talking through today. So fundamentally, we know that energy has to be reliable and affordable. This is the conversation that's at the forefront of the industry right now, as we think about the impacts of rapid load growth and who's going to pay for the infrastructure that's required to support it. In recent years, as I mentioned, the focus was more on sustainability and enabling decarbonization. We haven't necessarily lost sight of these climate goals, but the conversation has definitely changed. So that's why I've titled my presentation Rebalancing the Energy Trilemma. So my goal today in this presentation is to use the energy trilemma as a framework to talk about the challenges that utilities are facing and some of the trade-offs that are necessary for a strategy that allows us to do all of these three things to some degree at the same time. So before we dive into the content of the presentation, just want to remind you all of the role that utilities are able to play in the energy transition. Coming from the utility, kind of the scope of what we're able to focus on in our strategy is limited, because in New York, electricity markets were deregulated in the late 1990s, at the time with the goal of increasing competition and lowering prices. So as a result, utilities had to divest from their generating assets and are still largely prohibited from owning generation facilities, with a small number of limited exceptions. But when we talk about utility strategies for enabling the energy transition, the focus is largely on interconnecting new generation to the grid and ensuring reliability as that electricity is being delivered to customers. So I like this visual because it provides a cool view into what the future of electricity might look like. So today I'll talk a little bit about generation, but largely in the context of interconnections, and the solutions that I'm discussing will be focused on, the utility side of things, transmission and distribution. So we'll start out with sustainability, talking about what sustainable energy means for New York. Sustainable can mean a lot of things, but typically the conversation is focused on increasing the amount of electricity generation that's coming from renewable resources. The carbon reduction potential of electrification efforts is dependent on the carbon intensity of generation. So when we think about economy-wide decarbonization goals, they're tied directly to achieving a sustainable grid mix. In New York, we have statewide economy-wide decarbonization goals that were set by the Climate Leadership and Community Protection Act. The CLCPA was signed into law in July of 2019, and it lays out a series of interim goals, but the ultimate objective is reducing economy-wide emissions 85% by 2050. We can accomplish decarbonization through two primary means. The first is energy efficiency, and the second is fuel switching. So we can use less energy or we can use cleaner energy, but ideally we do both. The solution is going to be a combination of the two. So it's been 6 years now since the CLCPA was signed into law, so we have a good idea of progress that's been made. In October of last year, 2024, NYSERDA announced that the state hit its first goal, which was to interconnect 6 gigawatts of distributed solar. And we're seeing in the pipeline, we have enough solar in the interconnection queue where we're expecting to be able to meet that 2030 goal. So that's exciting. But in order to reach a grid mix that's comprised 70% of renewable energy by 2030, we still have a decent amount of progress to be made. Much of the renewable capacity that's shown in this chart is denoted as being in the pipeline phase, which means that the projects are not yet operational and are, in some phase of the interconnection process. And this is important to call out because a study by Lawrence Berkeley National Lab showed that the total time from interconnection request to commercial operation date for projects averaged about 5 years in NYSO territory over the course of 2018 to 2023. So said slightly differently, in order for the state to meet distributed solar, energy storage, and offshore wind goals for 2030, over 5 gigawatts of energy storage and 7 gigs of offshore wind should be entering the queue this year. But there have been some changes made by the federal government this year that are likely going to impact the further deployment of renewables. I'm sure many of you already know that the One Big Beautiful Bill is phasing out tax credits for wind and solar power. So that's going to impact the financial viability of some projects and is likely going to result in slower addition of new renewable generation. And then also in January of this year, the Trump administration withdrew leasing and permitting rights for offshore wind, which effectively halted development of offshore wind projects. In New York, the Department of the Interior ordered Empire Wind 1 to pause construction. This is a project that was expected to bring online 810 megawatts of carbon-free generation off the coast of Long Island. And then 3 other offshore wind projects in the state actually had their provisional contracts canceled as well. And this was because GE made a decision not to move forward with manufacturing of a new 18 megawatt turbine. And that decision impacted the bids and cost estimates that these developers used to win the projects or to win the contracts initially. So both of these developments have really put the state's offshore wind target in jeopardy, where it's seeming increasingly unlikely that we're going to hit that target. So without offshore wind, solar, and conventional wind projects, we'll have to close the gap. But this is increasing the pressure on interconnection queues that have already grown over the last decade. So the challenge here is that there's already a significant amount of capacity in the interconnection queue. This chart really makes it clear that the capacity in queues has grown significantly over the last decade. And it's great that developers are looking to bring more projects online, but in order for the decarbonization potential of these renewable resources to be realized, they have to be connected to the grid. They can't be stuck in the queue. So there are efforts underway by utilities and regulators to address this backlog of capacity that's stuck in the interconnection queue. In July of 2023, the Federal Energy Regulatory Commission issued Order 2023, which included a number of reforms to the interconnection process that's intended to help address these backlogs. The most notable of those was the requirement that transmission providers study projects in clusters. So traditionally, interconnection queues were just that. They were a queue, a line. And so the first project to file an application to interconnect was the first to undergo studies by the utility. But as you can imagine, this is a time-intensive approach. And so the new cluster study process requires utilities to group interconnection requests to study them. So we're able to look at all of the projects that might be impacting one substation at the same time. And so the added benefit of this for developers is that the cost of any necessary grid upgrades will be split using a proportional impact method. So this basically means that the developer is sharing the cost upgrades across all of the projects that are driving that upgrade. FERC 2023 is also aiming to reduce the number of projects that are dropping out of the queue once they've filed for interconnection. So there are 4 ways that this is happening. First, 2023 increased the amount that a developer has to pay as a deposit to the utility that's carrying out the study, so kind of increasing the barrier to entry. They're also requiring that the developer prove that they have the right to occupy or develop the site that they're looking at, making sure that that's all locked down. And then the developer is also being required to submit a commercial readiness deposit. And then lastly, utilities are now required to impose a penalty if developers are withdrawing from the interconnection queue. So these controls are in place to ensure that projects that are being submitted entering the queue are actually viable and hopefully deterring developers from submitting interconnection requests for projects that might not be built because utilities are spending time studying them, looking into upgrades, and then if they end up not happening, that's kind of wasted resources. So utilities are also working to make improvements to the interconnection process. Better internal data governance can improve the efficiency and speed at which interconnection studies are conducted. Transparency and accountability also improves relationships with developers and provides them with more insight into the schedule, study time, and different milestones. And then lastly, better training for developers should hopefully increase the ease with which customers are able to interact with tools that utilities are providing to facilitate the interconnection process, like the picture on the screen showing the hosting capacity, different parts of the grid where it makes sense to interconnect renewable projects. Some of these changes are still relatively new, so we expect that it'll take some time before utilities and developers are seeing the full impact of improvements, but it's important that, you know, we're kind of started down the right path. Now I want to talk about a different component of the CLCPA, which is the requirement that 100% of light duty vehicle sales be zero emissions vehicles by 2035. As far as I know, there's not a regulatory mechanism in place yet to ensure compliance with this, but I added in this chart because I want to talk about how even though a state might be setting climate targets or laws, ultimately it's customer adoption that's determining when and where upgrades to the grid will be required. So the top line on this chart is the policy scenario from the New York ISO's 2024 Gold Book. And this shows their forecasted percentage of light duty EVs in the state if the policy targets are achieved. So the assumption here is that EVs are going to make up 100% of sales share starting in 2035. But the second blue line is the baseline forecast from the 2024 Gold Book. And the assumption in this scenario is that only 85% of light duty vehicle sales in 2035 are electric vehicles. And the baseline scenario is basically expected load for the NISO territory. So they're planning for EV adoption to lag policy targets. The reason that this is important is because in thinking about strategy, there are trade-offs. So utilities and the ISO have to forecast how customer demand is going to change so that they know where and, more importantly, when to make upgrades to the grid. If utilities were just looking at state policy goals, you might end up investing in grid upgrades too early. And those are customer dollars ultimately that could have been spent elsewhere or earlier. So it's important that we have this recognition of the delta between policy targets and what we're driving towards in an ideal state and actual forecasted customer behavior. I also wanted to share this chart to illustrate how customer adoption of electric vehicles on the last slide translates to an impact on peak demand on the grid. I'm sure many of you know this already, but the system, we plan the grid, we plan the system to peak demand. So we have to be able to handle the absolute top load. So as EVs are increasing the system peak, we'll need to upgrade substations and other equipment, as well as increase generation in order to support this demand. In addition to electric vehicles, more customers are also starting to move from natural gas or oil heating to heat pumps, which are powered by electricity. So this transition is not only going to further increase peak load, but it's also expected to contribute to a switch from a summer peaking system, which we see right now with the load from air conditioning increasing peak, to a winter peaking system as heat pumps are the primary source for building heating. So as you can imagine, this introduces its own set of challenges because we know that solar production is lower in the winter, and then demand for natural gas for heating is then competing with demand for power generation, and that can increase electricity prices. So this conversation about balancing supply and demand is important for reliability, which moves us really nicely to the next section about reliability. So we started out with sustainability. The main challenge here continues to be interconnecting renewable resources to the grid quickly enough to meet decarbonization goals that are set by the state, while also keeping pace with increased customer demand. So now I want to talk about why that matters for reliability. We just took a look at that chart that shows the impact that electric vehicles and heat pumps will have on peak demand. We're also seeing increases in demand forecasts due to large loads, AI, data centers, onshoring of manufacturing. So this chart shows the total forecasted increase in peak demand for New York. The lower demand scenario, from what I can tell, seems to be a little bit more conservative than the 2024 Power Trends report. But the high demand scenario has actually increased and is showing that peak demand could actually double over the next 2 decades. I showed you earlier all of the capacity in New York's interconnection queue, but it turns out that retirements of traditional generating facilities have actually outpaced the addition of new capacity over the past few years. So this is another reason why it's important that renewable projects are able to move quickly through the interconnection queue. We need to be able to keep pace with state policy targets and customer demand, but we also need to make sure that new addition of new generation is keeping pace with the planned retirement of existing generating facilities. And the reason that this matters is because one of the factors that impacts grid reliability is frequency. So the frequency of the grid is impacted largely by the balance of supply and demand. The grid operates at a frequency of about 60 hertz, but once you start to deviate too far from that threshold, equipment that's connected to the grid starts to trip offline. So this is another trade-off. We want to increase the share of renewable energy that's responsible for generation, but the total pie, total demand, is getting bigger. So we're trying to interconnect as much renewable energy as possible, but we might not be able to retire natural gas plants if we need them to meet the peak. So we're starting to see reliability being prioritized over sustainability in the near term. It's also worth noting that earlier this year, the governor of New York, Governor Hochul, directed the New York Power Authority to build a new advanced nuclear power plant in upstate New York. And the press release for this announcement specifically states that the goal of the facility is to support reliable and affordable power. A new nuclear plant is also going to provide carbon-free baseload power, though. I've also seen some other articles about companies that are looking to repower nuclear facilities to support their data centers. So I expect as we see more large loads coming online, that we're probably going to see a bit of a nuclear renaissance. So speaking of large loads, they're one of the biggest drivers of the increase in peak demand that we're seeing or projecting to see. This map from NYISO shows that it's showing us, I think there are 29 large load projects that were in the queue in New York as of July of this year. And the total demand for these projects that's in the queue right now exceeds 6 gigawatts, that's about 20% of peak demand for the entire state in 2024. NYISO forecasters seem to expect that some of this is speculative, or projects will be bringing their own power, because the forecast for actual new demand that's going to show up from large loads is about 2.5 gigawatts by 2035. But nonetheless, these are still, utilities are using resources to look at the impact of these loads and try to figure out if we have enough capacity and generation to support them and get them online as quickly as possible. So in order to meet this growing customer demand, we need to ensure that we have adequate supply. We also have to make sure that we have the physical grid infrastructure to handle that added capacity. So to do that, utilities and other entities in the state are building new transmission lines. One of the projects I think worth mentioning is the Champlain Hudson Power Express. This transmission line is going to deliver hydropower from Quebec to New York City, and it's expected to be in service by 2026, actually. So we're kind of getting close to that coming online. And the reason that I think that this project is cool is because if you look at the carbon intensity for the generation mix in the NISO zones for upstate New York, about 70% of electricity upstate currently comes from zero emissions resources. But when you look at downstate, only about 2% of electricity is coming from zero emission sources. So statewide, about 28% of the generation mix is from zero emission sources, but the differential is pretty shocking. So it'll be cool to see this new transmission line come online. And we'll start to get, more renewable energy downstate. So these large-scale transmission projects are useful. They're definitely needed, but they're also really expensive. So the Champlain Hudson Power Express was expected to cost $6 billion in total. So we have another trade-off here. How do we manage affordability when these necessary grid upgrades to ensure reliability are costing billions of dollars and taking several years to complete? One of the ways that we can start to address this cost question is by using technology like advanced conductors and dynamic line rating. It's not a total solution, but it's certainly something that's being considered as we think about increasing capacity of the grid. So advanced conductors leverage innovative materials to increase the capacity of transmission lines. Utilities can reconductor existing transmission towers with these new advanced conductors. And so that eliminates the need to site and permit new right-of-ways, which can be a lengthy bureaucratic process. And then actually having to build new transmission towers. So these advanced conductors are kind of helping with some of those time delay aspects as well. They can also be less expensive because we're not building new infrastructure. They're also able to withstand higher temperatures, so they sag less. This helps safety and can also help enhance reliability. Talking about dynamic line rating, there are a couple different methods for doing dynamic line rating. One of the options uses LiDAR technology to monitor conductor sag in real time. So you can mount sensors on the tower to collect data about ambient weather conditions, and then that information can be used to adjust the traditional static or seasonally adjusted line ratings based on real-time conditions. This is important because many transmission lines are able to safely handle more capacity than just the seasonally adjusted or static rating. So using DLR can help to alleviate congestion in critical areas of the grid if we find out that we can safely add more capacity. DLR also allows utilities to optimize existing infrastructure, which defers or eliminates the need for costly and time-consuming transmission construction projects. And because they're just, sensors mounted on the tower, this technology can be installed relatively quickly, and the cost is a fraction of, again, siting, permitting, and building brand new towers and lines. So this is a cool solution because It helps to improve reliability by increasing the capacity of existing infrastructure, but at a lower cost, which helps us with affordability. So I want to circle back quickly to the point that I made earlier about how the balance of supply and demand impacts grid reliability. So the chart that we're looking at here is the sum of all electricity supplied to the New York grid on July 7th of 2024, I think. And this is at 5-minute intervals over the course of the day. We know that supply has to equal demand, so this is the demand curve for that day also. Worth mentioning, July 7th was a Sunday, so demand patterns for weekends and weekdays can be a little bit different, but we're still generally seeing the trend that we'd expect. And the peak for this day was at 7:40 p.m. So now we can take a look at the supply curves for wind and other renewables on that same day. Other renewables, I believe, is largely solar, but there are obviously some other resources in there because the generation overnight is still above 200 megawatts. So we can see the increase in supply in the morning as the sun comes out, as we'd expect, relatively flat during the day because it's summer, assume it was sunny. And then supply from solar drops off as the sun goes down. Wind supply peaks a little bit after 1 a.m., falls significantly in the early morning, and then kind of remains there below the other renewables curve. So this real life example does a really good job of illustrating the challenge of increasing our reliance on renewable resources. Supply from wind and other renewables is at its lowest actually right before 9 p.m., but demand is still near its peak then. So as more of our electricity comes from renewable resources, intermittent generation, we have to think about how we're going to manage this delta. So I'll show you with this chart what the generation mix looked like throughout that day to give you the full picture. Right now, what happens when solar and wind production drop off is that natural gas and dual fuel plants ramp up to help meet peak demand. And if you remember from my earlier slides, this peak is expected to grow over time. So the challenge is figuring out how we're going to meet that peak with a generation mix that's largely comprised of zero emissions resources. Some of that added hydropower from Quebec on that new transmission line will help. You can actually see that the curve for hydropower picks up to help meet the peak. It's also interesting to note that the nuclear generation on this chart is essentially a flat line. The difference between minimum and maximum supply for nuclear on this day was only 18 megawatts. So nuclear is helpful. I mentioned the governor, announced a plan to add new nuclear generation in upstate New York. And this is great because it's considered a zero emissions generating resource, but the efficiency of nuclear plants is optimized when they're running continuously near their capacity. So that means that the ability to follow load for nuclear plants is relatively limited. So it's going to be important that battery technology continues to improve so that we can essentially turn wind and solar into dispatchable generation assets as well to help manage reliability. This chart also doesn't take into account behind the meter solar. So from the utility perspective, distributed energy resource management systems, also known as DERMS software, that's starting to be adopted is going to be important for increasing the visibility of these distributed assets, where they're connected to the system, the size, because that will help with load forecasting, but also system planning. DERMS is also going to be increasingly important for helping control center operators manage reliability. Okay. So I've talked now about reliability on the system level, some of the challenges that come with balancing supply and demand. Now I want to talk about reliability at the customer level when you see outages at your home or your apartment. So the New York Public Service Commission is the entity that's responsible for regulating utilities in the state. Part of this responsibility is to set reliability standards for the electric utilities in the state. They also assess penalties if utilities aren't meeting these targets. So there's a financial incentive to make sure that customers have reliable service. New York uses two metrics to assess reliability. So the first is System Average Interruption Frequency Index, or SAIFI, and that's the average number of times that a customer is interrupted for 5 or more minutes during a year. SAIFI performance can be impacted by things like system design, levels of capital investment by utility, the quality of maintenance, and weather. In 2023, the statewide SAIFI performance was 0.58, excluding major storms. So that means, on average, customers across the state experienced less than 1 interruption in service throughout the year. The second metric is Customer Average Interruption Duration Index, or CAIDI, and that's the average duration in hours of an interruption for customers that experienced an interruption during that year. So CAIDI can be impacted by workforce levels, management of that workforce, and geography of a utility's territory. The statewide average for 2023 was a little bit under 2 hours, again, excluding major storms. Also important to mention, in 2023, the 3 major causes of interruption across the state, excluding storms, were equipment failures, tree contacts, and prearranged outages. So that gives us some insight into what investments utilities should be making to improve reliability. So we talked about innovation to help with increasing reliability by increasing system capacity. Innovative technology can also help to address reliability at the customer level. So FLISR technology, which stands for Fault Location, Isolation, and Service Restoration, is a grid technology that can help us improve reliability. And I'm going to go ahead and play this 30-second video for you because I think it makes the technology a bit easier to understand. We'll see if it'll go. Okay, so the way that FLISR works is by allowing reclosers on the distribution system to communicate with a central data concentrator that's using pre-programmed logic to tell feeders and equipment on those feeders how to respond in the event of a fault. As a result, that fault can be isolated only to the impacted section of the network, while electricity is rerouted to customers that otherwise would have been impacted. The control center is also notified when a fault occurs, so this allows them to dispatch crews pretty quickly if needed to address the fault. As a result of adding more FLISR technology, adding more FLISR schemes, fewer customers are impacted by a given fault, which is going to improve SAIDI performance. The communication with the control center can also decrease the amount of time that it takes for a crew to respond and address the cause of the fault. So this will improve CAIDI performance. The information provided to the control center can also help them to more accurately assess how many crews need to be dispatched and to where. So this is another thing that can reduce the cost of restoring customers. So Flizzr is a cool example of using innovation to improve both reliability and affordability. Another cool innovative technology is smart meters or advanced meter infrastructure. They can send power out notifications to the control center, which is eliminating the reliance on customers to be the one that are calling the utility to report an outage. This feature can also help to reduce the duration of outages because the control center is given greater visibility into the number of customers that are impacted, and then they can dispatch field crews, again, more quickly and more effectively. Smart meters are also going to help to enable time of use pricing, which is beneficial for both customers and the utility. So if customers opt into time of use pricing, they can actually save money if they're willing to shift their electricity use to off-peak hours. And then that helps to reduce the peak demand that utilities have to plan the network to. Smart meters are also providing usage data at 15-minute intervals, and this is then provided to customers, which can help them better understand how much electricity that they're using. There is an app that's compatible with like the newest smart meters that disaggregates load at the customer level. So it gives them insight into not only how much electricity is being used at that 15-minute interval, but which of their appliances, what parts of their home are using that electricity. So those insights can help to change customer usage patterns and, hopefully improve energy efficiency as well, just by providing that visibility. At the start of the presentation, I also mentioned that decarbonization can be accomplished through energy efficiency and fuel switching. So AMI giving customers this data visibility that they didn't have before should ideally allow them to make decisions that are improving the energy efficiency of their home. So we've now talked about reliability at the grid scale and at the customer level. The primary challenge here is maintaining the balance of supply and demand. As demand due to electrification and large loads increases the system peak, we'll have to increase the total capacity of the grid. We also have to make sure that we have the right mix of generation resources to meet this peak, supporting climate goals while also ensuring that we have reliable baseload resources. So lastly, we'll talk about affordability. At the start of the presentation, I mentioned that conversations in the industry have shifted largely to focus on bill prices. But in the prior two sections, talked about all of the challenges that are associated with sustainability and reliability. And kind of the bottom line there is that more investment into the grid will be required to accomplish those things. So how do we do it all? How do we, manage infrastructure and the necessary upgrades without burdening customers with high bills? There are two different ways that I think about addressing affordability. The first is the utility can decrease or more accurately limit cost increases for utility work through operational and capital efficiencies. And then the second way is by offering special programs and rates for low and moderate income customers, and then incentives for customers that are interested in adopting clean energy technology. So I'm sure you've all seen at least one headline about increasing utility bills. So I wanted to pull the data for New York State to show you what the increase for residential customers has been over the last decade. The average price of electricity for residential customers this year in 2025 is sitting at about 26 cents per kilowatt hour. In 2015, it was closer to 18.5 cents. So if you just take the percent difference, that's a 40% increase, but it hasn't been linear. The CLCPA was signed in 2019, and we've seen some associated bill increases since then. But it's really important that we look at this data in context. So looking at this study from EPRI, it shows that real electricity prices in the US, when they're normalized for inflation and household growth, have actually increased only 15% over the last 25 years. We can also see that total demand has risen over time, but the demand per household has remained flatter and is actually potentially starting to decrease a little bit. This is due mostly to energy efficiency measures, and should be, driven further by energy efficiency resulting from AMI. But this decrease is also partially from behind the meter solar. I think it's important to acknowledge that, 40% increase seems big. When we put it in context, 15% over 25 years seems a bit more manageable. But energy has become so essential for everyday life that utilities have an obligation to ensure that all customers, especially low to moderate income customers, are able to afford their bills every month. So even modest annual increases can really present a challenge for some people. So at the same time that we're recognizing the impact of rising energy bills, we're also seeing forecasts like this one from S&P Global that's projecting double-digit increases in capital investments by utilities. So in addition to spending on all of the things that I've mentioned earlier, like capacity increases, interconnections, grid upgrades, utilities are also trying to stay ahead of aging assets to ensure that reliability is not impacted. The increasing frequency and intensity of storms associated with climate change is also, increasing the tolerance threshold for some of these assets, which can mean that upgrades might be needed sooner. In addition to all of these investments that are required, also want to note that utilities are facing the same upward cost pressures from tariffs on critical materials like steel, aluminum, and copper, as well as general supply chain volatility. So these costs, because they're ultimately passed on to customers, it's important that we have, as a utility, a procurement strategy that helps to mitigate these increases and find a way to source materials at the lowest cost possible. So before we get into strategies for managing costs from the utility perspective, I just want to talk quickly, give a refresher about how a utility makes money. So the Public Service Commission in New York is responsible for approving utility rates, and this occurs during the rate case process. Formal litigation of the rate case process can take about 11 months, but as you can imagine, it takes the utility just as long, if not longer, to prepare. And the rate case process is public and open, so all of the documents are published on the PSC's website, and members of the public, special interest groups, and other interested parties can participate. So, there's an opportunity for people that are maybe upset about the cost of electricity and their bills to go ahead and comment and participate in this public process. So utilities earn recovery for costs through the rates that we charge to customers. The revenue requirement is what's used to calculate rates, and it's based on the number of customers and the forecasted demand for the service territory over the course of the rate period. The revenue requirement, which is determined during the rate case proceeding process, is equal to a utility's operating expenses, which includes things like labor, plus capital expenses times a return on equity. So the return on equity is negotiated during the rate case proceeding as well, but this is what determines the utility's profit. So operating expenses are a pass-through cost, and the utility earns on capital investments. So when we think about affordability, utilities can manage costs by decreasing or more realistically limiting increases for either operational expenses or capital expenses. So while recognizing that a significant capital investment is required to build out the grid, facilitate the energy transition, there are ways that utilities can conduct work more efficiently to drive down unit costs. Operational efficiencies can come from process improvements that are allowing people to spend less time on a given task or engaging with a certain process. Better data availability and visibility can optimize decision making about where and when we're investing time or money. And digital tools can facilitate both of these improvements. Capital efficiencies can be driven by optimizing designs, like finding opportunities to tweak standard designs for substations or other equipments to reduce costs while maintaining safety and performance. One of our big risks right now, like I mentioned, is supply chain instability. We've seen costs for critical materials like steel, transformers, and conductors increase over the past several years, even more so with some of the recent tariffs. We've also seen increased lead times. So the amount of time that it takes to actually receive materials once they're ordered is going up. Again, for things like transformers and conductors that are critical for grid upgrades, some of these lead times have actually doubled in some cases. So one of the ways that we can combat this is by forecasting materials that are going to be required for projects well in advance of when they're actually needed to help mitigate risks to the budget and also to the schedule if materials don't show up in time. And again, we're seeing use of digital tools providing capital savings by improving work methods and project management, facilitating better communication among teams, and again, just providing, team leaders, executives with the data visibility required to make optimal decisions. So I want to give you an example of how operational efficiency initiatives can be impactful and deliver savings for both the company, but also give benefits to customers. So if we look at something like vegetation management, when we talked about reliability, I mentioned that trees making contact with power lines was the second biggest cause for interruptions in New York in 2023. And I'm not sure if as a class you still read the case study about the 2003 blackout, but the cause of this blackout that impacted 50 million people is largely attributed to a tree making contact with a transmission line. So, around a third of the OpEx budget for a utility can be spent on vegetation management programs to prevent other outages caused by tree contacts. So vegetation management programs are in place to regularly trim trees that exist near power lines. And then we also want to look at removing hazard trees. Typically, this is done on a time-based cycle. So based on an arborist's knowledge of regular growth rates in an area or observing tree growth encroachment, a certain section of the network might only be trimmed every 5 years. But there are companies that are looking to optimize this process by using technology and digital tools to facilitate, again, data-driven decision making. So some of these solutions can use satellite or LiDAR imagery to enable what's called condition-based pruning. So instead of trimming a section of the network on a fixed schedule, imagery can be collected, and then a machine learning algorithm can be applied to, forecast growth rate for these trees, and then identify when sections of the network actually need to be trimmed based on the growth rate. So this technology will, provide greater visibility, and it allows utilities to better prioritize which sections of the grid, which areas need to be trimmed in a given year. This increased visibility can also help to reduce contractor costs, because the utility has better information about the amount of work that's actually going to be required, so they can sense check and push back on quotes from third-party contractors that are doing this work. So the overall result is going to be a reduction in operational expenses, that money could then be invested in network upgrades to support reliability or decarbonization. Reliability is also improved with this method because teams have better information about which trees are going to be the most likely to come in contact with the network, and then proactive measures can be taken to trim that section, before it becomes a problem. And then technology like this also promotes affordability, because the cost to achieve the same outcome is lowered. So really cool solution, really cool technology, that I think is kind of representative of the future of electricity. We're able to address sustainability, reliability, and affordability by incorporating digital tools and giving people more insight. So talked through the first part of affordability, which is the utility identifying opportunities to reduce costs by doing work more efficiently. The second part of affordability comes from special programs and incentives. So there are a few ways that utilities in New York are addressing affordability for low-income customers, while also incentivizing the adoption of clean energy technology. So the first, utilities in New York State administer the Energy Affordability Program, which provides eligible customers with discounts on their monthly bills. This helps to ensure that low-income customers are not energy burdened. The Empower Plus program is offered by utilities through a partnership with NYSERDA. So income-eligible customers are paired with a participating contractor who will complete a home energy assessment at no cost to the customer. These customers can also receive energy efficiency improvements at no cost, and previously were able to receive rebates through the Inflation Reduction Act, with funding that was made available to install heat pumps. I'm not sure about the status of that funding, to be honest. The New York State Clean Heat Program allows utilities to offer incentives for customers to install heat pumps. And incentives for this program are calculated based on the heat pump system capacity, but are generally several $1,000s on average. And this incentive is intended to support the state's building decarbonization goals and make clean energy technology more accessible. And then lastly, the EV Make Ready program is another program that's administered by utilities in the state in support of the CLCPA goal that I mentioned to increase the number of electric vehicles in the state. Utilities are providing incentives for commercial customers that are looking to install EV chargers at offices, retail stores, apartment buildings, and other public destinations. And these programs will fund up to 100% of the electric infrastructure costs that are associated with installing the charging stations. So again, helping with cost and accessibility for clean energy technology. So we've now talked about all three components of the energy trilemma. State decarbonization targets are dependent on the fast interconnection of renewable energy resources to meet growing demand from customers and large loads. But as we interconnect more renewable energy to the grid, we have to ensure that we're not jeopardizing reliability and that we can keep supply and demand balanced. We can leverage grid enhancing technologies like advanced conductors and dynamic line rating to increase the capacity of the grid. We can also ensure the reliability of the distribution grid by using technology like FLISR and AMI to reduce the number of customers that are impacted by an outage, as well as the time it takes to restore customers. While we're conducting this extensive grid build out, we also have to maintain affordability. So we can look to a combination of process improvements, digital tools, and improved data visibility to drive operational and capital efficiencies to keep cost impacts on customers limited. Utilities can also offer targeted programs to ensure that low-income customers are not energy burdened, as well as incentivize the adoption of clean energy technologies. So as this presentation hopefully made clear, there's no silver bullet. There's not one solution that can address all of these challenges. We've been so reliant on fossil fuels to generate electricity for over a century that the transition is not going to happen overnight, especially as we're seeing unprecedented load growth from AI and data centers and onshoring of manufacturing again. So a comprehensive utility strategy for managing changes to the energy landscape is going to require innovative solutions because these are complex interdisciplinary problems. There are also trade-offs that have to be considered because we can't sacrifice reliability or affordability for sustainability. But addressing climate change requires rapid action. So we're managing all of these shifting priorities all at the same time. And it can seem like it's hard to keep up. But I think that's why it's such an exciting time to be working in the energy industry. I really appreciate the opportunity to present today, and thank you all for your attention. If you have any questions, I am happy to do my best to answer them.
Oh, thank you, Laura. Excellent presentation. So I'm opening the questions to the students who are assembled here at the meeting, at the workshop. Students, questions for Laura?
Hi, Laura. Thank you for a great presentation. That was really insane details, and I loved every bit of it. I have a question about nuclear. So since you mentioned how there's like the Governor Hochul and federal government pressures to increase more nuclear, what do you think are the most important parts that come with nuclear that will help make it go by faster to deploy in New York? Because I feel like there aren't any existing projects that have any like contracts signed with any companies or anything. So what do you think will make it go by fast, basically?
Yeah, I think that's a great question. I was also, curious how development of a new nuclear plant in New York was going to go, because the most recent nuclear generating facility to come online was in Georgia, and as we all know, that project was overcost significantly and took a lot longer than expected. So my expectation is probably that the state will probably be looking to advance nuclear, like small modular reactors potentially, if we're able to deploy like a series of small modular reactors instead of a brand new full-sized nuclear plant. I think that's a possibility. But I am also really curious to see you know, where NIPA goes with that. I think it'll be, you know, kind of an interesting next evolution to nuclear in the country. So,
Thank you.
yeah, thank you.
Questions for Laura from the students here?
Hi, Laura. Thank you for your presentation. My name is Bintu Silla. I'm an ESE student also. So I wanted to know, talking about the trilemma between affordable, reliable, and sustainable. I just feel like there is no middle in these three. We just have to sacrifice or minimize one among the others. And now, especially that AI data centers have joined the discussion, reliability and affordability are more endangered. So, what do you think is the right way to find the balance between these three?
Yeah, I don't know that there is necessarily a right way. Like I mentioned, this is a super complex problem. Pretty much all of our solutions have trade offs that we have to make. I do think that in the near term, sustainability is kind of being deprioritized a little bit because reliability and affordability have kind of become the more pressing issues. There was a very significant push to meet sustainability goals, you know, as quickly as possible. So utilities were making a lot of investments. But now that customers are starting to feel the impact in their bills of the cost of those investments, I think we're seeing, you know, state governments ask utilities to pull back a little bit, slow down, say we can't do this to customers. People have to be able to pay their bills. So I think that's kind of the rebalancing that we're seeing. We kind of had our foot fully on the gas pedal for sustainability, at least in New York, for a few years. But now, as we're seeing the costs, and we're also seeing, you know, reliability concerns, I think we're prioritizing solutions in the near term that will drive down costs and maintain reliability and health of existing assets as opposed to build.
Thank you.
Yeah, of course.
Questions from students to Laura?
Hi, Laura. My name is Eunice Kadzima. I'm also an ESE student. I was just curious. We are talking about all these changes as we move forward in the energy transition, but what are some of the skills that energy systems engineers need to maybe have as we move towards the future? Because a lot is changing. So maybe things that you learned in your career that we can take on, or skills that we might want to have moving forward.
Yeah, that's a good question. I think, at least in my role, you know, critical thinking and the ability to synthesize a lot of different information and problem solve and develop potential solutions is what's most critical. I think we talk about AI being both the problem and the solution, in that AI can help replace some repetitive tasks in the workplace. We can kind of outsource things to AI, but it's also driving up demand. So I do think that the types of tasks that will be replaced by AI are going to be more repetitive. And so the value that you can add as a new graduate is going to come from being able to think at this strategic level, to synthesize information, to make recommendations, to understand how different things, how different parts of the business are interacting, what broader trends in the industry mean for the company. So I do think that, as far as skills to focus on, probably critical thinking and problem solving, which I think this program sets you up super well to do, provides you with all the tools that you need to do thinking at the systems level. So
Thank you.
Questions from students? Okay, I'm going to now ask the general audience. You have any questions for Laura? Please
Hi,
unmute yourself.
Hi, Rudy. It's John McCauley. Can you hear me?
Yes, we can hear you. Go ahead, John.
Okay. Hi, Laura. Thank you for your presentation. So on affordability, I'm in my car and I just not moving, but I just Googled cost per kilowatt hour by state, and the span is actually greater than I thought. The lowest state, and I forget which one it was, but is like 8 cents per kilowatt hour, versus Hawaii being like almost, if not more than 3 times as much. So my question is, who, maybe it's a stakeholder question, but who determines it for the jurisdictions that you operate in? Who determines whether electricity is considered, quote, affordable now, and how affordability would be determined in the future, given that everything gets balanced, right? Everything's a trade-off, but which stakeholders have the most, I'll call it street cred, when it comes to determining, hey, electricity is now getting beyond affordable for where we are, recognizing that the baseline for where you operate, every state has its own averages. And I guess this might be a sort of a rate case issue. It always was, and I expect it always will be. But who determines? In other words, is a cents per kilowatt hour rate index compared to, let's say, the states or the jurisdictions' consumer price index a measure? In other words, as long as we're not growing beyond the consumer price index for inflation, we're doing well, or is there something else to it in terms of I'll call it a numerical measure, not a subjective, or a look back over, hey, it's not so bad because the cost per adjusted for inflation, adjusted for the increasing size of the house kind of thing. That's more of a justification for why it's okay. But my question is, in the future, how will this battle be fought?
Yeah, so to my knowledge, the most common metric that's used to gauge energy affordability is called an energy cost burden. So I believe that threshold is 6% of average household income. So it's less about cents per kilowatt hour and more about, based on price of electricity and average use, what is a family spending each month on electricity? What percentage of that total household income does energy represent?
Okay, thank you.
Yeah. I think it's cited in one of my slides. So if you get the deck afterwards, there's a cool study from EPRI on energy share of wallet. And so it looks at electricity prices as well as spending on natural gas for heating and fuel for vehicles.
Sure, yeah.
So there are some cool studies there looking at energy share of wallet and, how adoption of electric vehicles can impact energy share of wallet if you're no longer spending money on gasoline, but maybe your monthly electricity bill is increasing. So
Understood.
That's what I would look into. Yeah.
Okay, thank you.
Yeah, of course. Thanks for the question.
Questions for Laura, general audience. Please unmute yourself, introduce yourself, and ask a question, please. Questions for Laura? You can drop the question in the chat box if you want.
There is one in the chat, Rudy. Larek says, "Hi, Laura. Thank you for a brilliant presentation. You mentioned AI data centers, but I was also wondering if National Grid is looking to partner with Bitcoin mining companies as well, since electricity costs amount to 60 to 80% of OPEX for them. Thanks."
Yeah, thanks for the question. I don't know that partner is necessarily the right word. Maybe it is. Um, as a utility, we of course are going to evaluate any interconnection requests that come in. I don't know specifically if there are any Bitcoin mining companies in our territory that are looking to come in. But if they are, of course, would be investigating ways to serve that load. I do know that, and I'm not as familiar with where this is going to land, but there are conversations at the New York state level and also at the federal government level now between FERC and DOE looking into designing a specific rate class for large load customers because, like you mentioned, electricity is a significant amount of their costs. But if they're, if we have a customer coming looking to add 1 megawatt or 1 gig of load to an already constrained area of the grid, it's maybe not necessarily fair to distribute the cost of those upgrades across the broader rate base. So I'm interested to see kind of where this conversation will land and where that will progress. But certainly there are conversations nationwide about how do we handle the cost of large loads.
I have a question. Thank you so much, Laura. You mentioned the transition to a winter peaking system. From a capacity standpoint, what are the impacts? Because days are shorter, in the winter, so I'm assuming there's less solar generated. I don't know what wind output looks like in the winter versus summer, but from a capacity standpoint, what are the impacts? Are there going to be more peaker plants used or called, or what are the impacts?
Yeah, I think the impact will depend a little bit on what our generation mix looks like. And that's, I think we're still at least a decade out from kind of that switch to the winter peaking system. I don't remember exactly where the inflection point is. But yeah, certainly we'll see less generation from solar. So we'll be looking to baseload resources that could be nuclear, it could be wind paired with storage, but likely it will be peaker plants. In the most recent New York State Energy Plan, the state actually acknowledged that a lot of the peaker plants that they expected to be able to retire by, I think, 2040, we're still expecting to need them online for reliability purposes. So I think in the near term, continued dependence on natural gas is probably going to be one of the biggest impacts there. Even though we're moving away from natural gas for heating towards heat pumps, we'll still need that natural gas to generate the electricity to power the heat pumps.
Awesome. Thank you so much.
Yeah, thank you.
Questions for Laura? Questions for Laura? Please unmute yourself. And there's a question here in the chat box from Anu Goyal. You mentioned the difference in the areas of energy generation between upstate and non-upstate New York. Please talk about why this difference exists.
Yeah, that's a great question. So the primary reason is geography. If you think about upstate New York, it's much more rural. There's a lot of land, and so you can develop wind farms and solar farms on that land. So there's much more land available to host renewable generation resources. In downstate New York, New York City and Long Island are more densely populated. And so I think we're starting to see more solar on rooftops in New York City, but the amount of space available compared to the demand is much more disparate downstate. So we see a lot of projects being built in upstate New York where there's land available, where real estate is more affordable. And so, that's just where most of the generation exists.
Laura, I have a related question. There's Manhattan's got obviously a lot of rooftop space, What percentage of those rooftops are utilized to generate electricity? You know,
Yeah, that is a great question that I do not know the answer to.
no, but I think it's utilized. I mean, that's my general feeling.
Yeah, I would be inclined to agree. New York City, so New York State has climate goals. New York City also has climate goals. So I know that the city government is working on adding solar panels to rooftops of government buildings, but I'm not sure what efforts look like, um, for private companies and residential buildings.
Okay. Related question. You showed the very first few slides that offshore wind is going to fall far short of the target for reasons that cannot be explained. So, is there a plan B for that, or are they waiting for some things to happen?
I'm not sure, to be honest, because in addition to offshore wind projects being canceled, tax incentives for onshore projects are being phased out. So I don't know for developers if looking into wind projects right now is, financially viable, if that's something that they're looking at. Um, I guess it's been close to a year now since that development, but I haven't heard a ton of conversations about what the pivot might look like to address that gap. Aside from the governor announcing that she'd like to develop more nuclear in the state. So,
Yeah. All right. Thank you, Laura. Any more questions for Laura?
Yes.
Joe. Yes.
Yes. I was really excited to hear about the smart metering. I think that's going to be a major advance, especially as people can load shift, time of day and really help out. So it's a good example of how technology can help. Uh, One other question though I had, and maybe this is totally out of bounds, but everything you talked about was relative to the state of New York. What would happen to electrical distribution, consumption, et cetera, in the US if the net was casted more broadly? Like look at geography rather than just, the state of New York, the political state of New York. I see you mentioned you're getting energy or power from Quebec. Are there other, how would that change all your thinking and strategizing if you didn't have, these state boundaries to look at?
um, that's an interesting question. Do you mean in terms of like
Well,
if there
perhaps.
wasn't New York State specific policy to guide decision making?
Yes, yes. In other words, you're imposing like political restrictions on, uh, maybe technical or physics questions. Where's it best to generate energy, and where would it be best? You mentioned the difference in geography between northern New York and southern New York. Well, adjacent states. I don't have to think about it, but what are the adjacent states? Maybe they're more capable of providing energy to New York, but they're not in the state.
Yeah, so there's still imports and exports to
There
neighboring
are, okay.
states. There are imports and exports the same way that hydropower will come down from Canada. There are also imports and exports to PJM into the New England ISO. So there's already a degree of that. Once
Okay.
once it's an electron on the grid, it flows where it flows. So
Okay.
neighboring RTOs are doing what they can to support reliability in that way.
Thank you.
Yeah, thanks.
Just generally speaking, Joe, I think it's not that they're adverse to getting energy from point A, maybe 1,000 miles away. It's just that they have to pay for those transmission line traffic, and that seems to be the biggest actually financial impediment. If they weren't, if they had the liberty, they'd probably go ahead and do it. but the cost would have to be borne by, the the requester who may be many thousand miles away. I think that's the big preventive reason, I think.
Gotcha.
Questions for Laura? We got a few
Yeah.
more minutes.
Hi,
Yes.
Laura. It's me again. I just have a question on, do you and other utilities in New York ever collaborate to try to reach these goals together? Because I know there's the New York State like energy goals and there's the New York City energy goals, but are there any times where you guys collaborate?
Yeah, absolutely. So there is a group called the Joint Utilities of New York, and there are a ton of different working groups. So there's one for advanced transmission technology right now. There's one for integrated energy planning, which is looking at strategically electrifying sections, areas of the grid so that we can retire leak prone gas pipeline. And there are several others. I think there's one for large loads right now. So one of the advantages of being a monopoly is that provides a ton of opportunity for collaboration without necessarily a threat to your customer base. So there, is a ton of collaboration between the different utilities in New York. Everybody's trying to solve, a similar set of challenges. So putting heads together where we can makes a ton of sense.
Awesome. Thank you.
Yeah, of course.
Anyone else?
We have time for one last question for Laura. All right. Having no questions, thank you again, Laura, for a wonderful presentation. And folks, this brings to an end our fall presentation series. And we'll be back in the spring with a theme that would probably be revolved around AI, but we'll start around the third week of January or so. But thank you for your attention to this seminar series. And I also would like to ask the audience here if they want to make a presentation in the near future in one of these seminar series, please shoot a note to me or to Susan, and I would be glad to kind of entertain your request. Well, thank you again, and have a great rest of the year. And I'll see you back next year. Thank you.
Thank you all.
Thank you.
Thank you, Laura.
Thanks all.
Thank you, Laura.
Thank you.
I will make sure to send you a copy of my deck right after this, Dr. Shankar, so that you're able to share with the students.